Hello students, welcome to Unacademy. कैसे हैं आप लोग? So I hope your preparation is going absolutely fine and most welcome to this concept capsule series. It is a second capsule basically. So in first capsule we already seen the angular momentum equation or moment of momentum equation. Basically we talk about the specular problems and I hope you enjoyed that session. So now in this session I'm going to continue the series. This is a second capsule and today we are going to talk about the continuity equation. So basically we are going to discuss what is this continuity equation, how it is based on the law of conservation of mass, and what is the equation for one dimensional and for three dimensional, and what type of questions can be framed. Even 3-4 problems also we are going to solve here. So if audio video everything is fine, please just let me know in the chat box. So that we can continue. And even I told you that if you need any modification, if you have any problem in any of the concept related to the thermal and fluid area, please let me know. I'll prepare one capsule for that. Now the USP of this capsule is I'm not going much detail in the concept, but overall whatever things are required to solve the problems that I will give you. Not only this, we will solve the expected problem, or like suppose for like yesterday capsule 1 we seen. So in that one only 2 type of problems can be framed mostly, so those problem we already discussed. So like that also here also today also we are going to see 2-3 type of problems are there that can be framed and we'll solve those problems. So if audio video everything is fine, please just let me know in the chat box. And as I told you that this particular session, right, this session I am going to continue and every day, approximately every day 6 p.m. one capsule will be delivered. But the thing is, you have to come live. So if you people will come live, and then only I'll continue this series, right? Otherwise, after few capsules, I'll stop this series. So if you want from my side that this series should be continue, then please share this session. Please like this session. Please share with your friends so that more and more people will come on live. And don't watch it in recorded mode. Like you can watch, if you suppose missed or something, then okay, fine, but try to come in live and clear your doubts immediately. Okay, so is everything is fine? Yes, very good. So I hope now I'm visible to all of you. Now I'm perfectly visible and everything is perfectly fine. So these capsules are basically designed. See, if you look at any particular subject, then in every subject 10 to 15 concepts are there through which most of the questions are coming, or the question like probability of coming question is more. So I am going to discuss those concepts. So if you see fluid mechanics, thermodynamics and applied thermodynamics, maximum I would say 30 concepts are there through which the majority of questions are going to be asked in coming GATE exam. So even if you are completing these concepts capsule, then definitely you can secure almost full marks, or suppose thermal and fluid area 15 marks is coming for example, or 18 marks is coming. So out of that 18 marks, easily you will get 14 to 15 marks. This is my guarantee, this is my promise. Okay, थर्मल बाबा की जय हो. पीके नाग साहब आप आ गए, मेरा दिल खुश हो गया. राइट, व्हेन पीके नाग साहब जिनसे मैंने सीखा है, आई एक्चुअली लर्न फ्रॉम दैट बुक एंड ही इज इन माई क्लास. आई नो ही इज सम बॉय ओनली बट ही इज राइटिंग पीके नाग. अरे भैया इतने बड़े आदमी का नाम मत यूज करो भाई. ओके, shall we continue? So if you give me the thumb, like just like the session, I will start. Just like the session fast, I will start immediately. Just like the session, I will start immediately. And please share this session also. Please share the session also. Why? Because if more people will get, I will get more energy and I will deliver these concepts in much better way. So today I am going to discuss continuity equation for one dimensional as well as three dimensional, one dimensional and three dimensional. So you need to pay some fees. Sir, what is the fees? Fees is very simple. You have to share the session and like the session, and every day you have to come on live. ठीक है, स्टार्ट करें। लाइक कर दो जल्दी से, तो स्टार्ट कर दे यार, लाइक कर दो तो जल्दी से स्टार्ट कर दे। टाइम बहुत खराब करते हो भाई, एक छोटा सा काम बोलता हूं वो भी नहीं करते। Shall we start? बोलिए बाबू, shall we start? Okay, let me start the session. Okay, so before starting this session, I just want to tell about myself. I am Shivam Dixit. I did my MTech from NIT Calicut in thermal science. After that, I got selected in many PSUs including IOCL R&D as automotive research officer, and from last 10 years I am guiding the GATE and ESE aspirants, and up to now I have guided more than 50,000 students, and many of my students secure single digit and double digit rank. This is all about me, and let's start directly on the continuity equation. So continuity equation is basically based on law of conservation of mass. These are based on law of conservation of mass. So what is law of conservation of mass? That you need to understand. What is law of conservation of mass. Okay, first I'll tell you what is law of conservation of mass in engineering perspective. So for unsteady flow, in general flow, right, in a control volume, the rate of mass entering is equal to the rate of mass leaving if flow is steady. Sir, I did not get it. Okay, no problem. Just assume that suppose you are sitting in one room. That room is basically your control volume. In that room, one door is there. From that door, 10 kg per second mass is entering. 10 kg per second mass is entering, and from another window, 8 kg per second mass is leaving. So if you say that, write the mass balance equation, then I will write here 2 is equal to 10 minus 8. Sir, what is this 2 is equal to 10 minus 8? Right? 10 is entering, 8 is leaving, right? So how much is going to accumulate? That is 2. So 2 is basically what? Rate, because 2 kg per second is going to be accumulated. So rate of mass accumulated. 2 क्या है? 2 is rate of mass accumulated per second. And 10 क्या है? 10 is rate of mass entering minus rate of mass leaving. Now my question is, this flow is steady or unsteady? Definitely it is unsteady, because if the mass is going to accumulate within the control volume, it means that it will change the properties of the control volume. If properties of control volume is changing, it means it is an unsteady flow. So for steady flow, the properties of control volume should not be changed. And when it will be possible? It will be only possible if the mass accumulated within the control volume is 0. So if this is 0, this is unsteady flow. This is unsteady, right? It is unsteady, right? Now if this value is become 0 somehow, when this value will become 0? When this value will become 0? When the rate of mass entering must be equal to the rate of mass leaving. Now this equation is basically for steady. Now I am saying the same thing in words. In unsteady flow, the rate of mass accumulated within the control volume, is equals to the net rate of mass transfer across the control volume. Now for steady flow, there should be no any accumulation of mass within the control volume. It means that the rate of mass entering must be equal to the rate of mass leaving. So these two statements you must know. So I hope you already know about this statement. Okay, now sir, how we are going to apply this mass balance equation? Don't worry, everything you are going to get crystal and clear. This is my promise. So first I am going to talk about 1D, right? One dimensional flow. One dimensional flow means the flow is going to take place only in one dimension, right? Unidirectional, like say x direction only, no flow in y direction, no flow in z direction. Okay, let's say this type of arrangement is there. Just for your simplicity, this type of arrangement is there. Now this is our section 1, this is our section 1, right? This is our section 1 and this is our section 2, and this is basically our control volume. This is basically our control volume. This is basically our control volume. Now from here, mass is entering. Mass is how much mass in M1 dot is entering, right? Here how much leaving? M2 dot is leaving. M2 dot is leaving. Here at point 1 properties are denoted by suffix 1, and at point 2 properties are suffix 2. Okay, now first thing I'm going to take here, first thing is, first assumption I have already taken, that is one dimensional. First assumption I have already taken, that is one dimensional. Second assumption I'm going to take steady flow. Steady flow. What do you mean by steady flow? Steady flow means there should be no any accumulation of mass within the system. It means that rate of mass entering M1 dot is equal to rate of mass leaving, right? Rate of mass entering must be equal to the rate of mass leaving. Now what is the value of this? You must know. Okay, wait. Please ask the doubts after when I complete my discussion, right? Now rho is equal to what? Rho is equal to mass per unit volume. So mass is equal to rho into volume, but I am not interested in mass. I am interested in m dot, rate of mass, because it's an open system basically, right? So time. Okay, no problem. So this will become m dot. This will become m dot rho. Velocity I am writing a. Okay. Sorry. So this this volume, this is volume basically, right? So volume I write area into L by time, Now L by time is velocity. L by time is basically, this is velocity V. Velocity I'm representing V. So m dot value will come rho AV. M dot is basically rho AV. So what is M1? M1 is rho 1 A1 V1. M dot is rho 1 A1 V1. So here M1 dot I can write rho 1 A1 V1 is equal to, means A1 is the area at section 1, V1 is the velocity at section 1, rho 1 is the density at section 1, is equal to rho 2 A2 V2. This is basically one dimensional continuity equation for steady flow. One dimensional continuity equation for steady flow. Okay, now if flow is incompressible. Incompressible means what? Incompressible means density is also not going to change, means rho 1 is equal to rho 2. So then in that particular case I can write here A1 V1 is equal to A2 V2. A1 V1 is equal to A2 V2. So this is the most applicable, like this is a very important equation. Not directly, mostly you can say, sir, mostly questions are not asked directly from this this particular equation. Okay, that is fine, but whenever you are going to apply Bernoulli equation or momentum equation or impulse momentum equation, then this equation may be helpful. Even yesterday we solved two problems basically. In both the problem this equation were used, right? So this is basically continuity equation, but what are the assumptions? One dimensional, second assumption is steady, and third one is incompressible, right? So this is A1 V1 is equal to A2 V2, very important equation. And if it is not, if it is a compressible fluid flow, then we have to use this particular equation. Okay, so this part we already seen, but this part, sir, I already know. What is new in that? The new thing is, now I am going to give you the generalized equation. Generalized equation means where there will be no any assumption, means it will be not 1D. I am going to give you the for 3D. It will be not steady, it may be unsteady. It will not incompressible, it may be compressible. So now I am going to give you the equation, continuity equation, free from all the type of assumptions, For that continuity equation in differential form or 3D form. But before that, one more thing I would like to share here, that discharge, there is one term used, discharge, and discharge is what? Discharge is basically known as volume flow rate, means Q is represented by Q, and Q is nothing but a volume flow rate, means volume per unit time. This is basically what? Volume per unit time. Volume per unit time. Okay sir, thank you sir. Okay, volume can be written as A into L by time, and this is going to be velocity. So basically I can write Q is equal to A into V. Q is equal to A into V. Now if I write for one dimensional study incompressible flow, what I can write beta? What I can write here, that A1 V1 is equal to A2 V2. What is A1 V1? A1 V1 is Q1 basically is equal to Q2. So I can say that for one dimensional study incompressible flow, the discharge is constant, but only for one dimensional study incompressible flow. If it is not incompressible, if it is compressible flow, then discharge may change. If it is not like unsteady, then also it may change. If it is two dimensional, then also it may change, right? So we'll see. Okay, let's talk about the continuity equation of differential form, or better way you can say in 3D. So here all three direction I am going to take. So it is a fluid element. You can see this is a fluid element, and this is the origin basically. This is the origin, right? And this I am taking as a, this is, let's say, x-axis. This is, this I can write y-axis, this I can write z-axis, right? Our normal convention, right? So now I am taking this length as a dx. This is, let's say, dx or delta x you can write. This is basically dz, and this is basically dy. This is basically dy. Now please listen here. First now here the flow is taking place in all three directions, means it is entering in x direction also, leaving in x direction also, entering in z direction, leaving in z direction, entering in y direction, leaving in y direction. So it is basically in all the direction. Okay, let's talk about x direction first. I am going to talk about x direction. We already know that in our fluid kinematics, velocity vector v is represented at ui plus vj plus wk, right? What is this equation? Now in this equation, u is what? U is the velocity in x direction, v is the velocity in y direction, and w is the velocity in z direction. In all these three directions, this is there. Okay, no problem. Now this, I'm going to take this particular phase, this one I'm going to take, this one I'm going to consider, right? Through this plane, mass is entering in x direction. Let's say this is A, B, C, D. Okay? And from this particular phase, mass is leaving in x direction. So this is, let's say, A dash, B dash, C dash, and D dash. Clear hai? Please listen here carefully. So how much mass will enter here? So whatever mass is entering in A, B, C, D plane, whatever mass is entering, that is basically that have velocity of u, density is, let's say, rho. So here I can say the m dot value is rho av. So here I can say rho into A. Area kitna aega? This area will come dy into dz. So this value will come dy into dz into u. ठीक है? Clear है बेटा? Or in better sequence if I write, then I can write rho into u dy and dz. Now how much mass will leave? So that we can find out with the Taylor series expansion. With Taylor, I'm not going to explain Taylor series expansion. You already well aware about it. If anyone have any confusion in that, you can ask me. I will clear your doubt, right? No problem. So what is the value? How much it will leave? So rho u plus, right? Rho u plus rho u by dou x into dx into area means dy dz. So this much mass is going to be leave. So mass entering is rho u dy dz. I mean rho av. Basically this is what rho av. This is basically Taylor series expansion. Similarly I can write in y direction. Similarly I can write in z direction. Similarly, right? Now I am going to apply the law of like net rate of mass transfer in x direction, right? Net rate of mass transfer in x direction. So net rate of mass transfer in x direction. So this value will come how much? Rho into u into dy dz is entering and leaving is how much? Minus dou by minus rho into u plus dou rho into u by dou x into dx into dy dz. Clear hai? Now first term is going to be cancelled out, so finally you are getting minus dou rho into u by dou x into dx dy dz. Now this is in x direction. Similarly in y direction, similarly I can write here, similarly net rate of mass transfer in y direction, right? y direction में क्या हो जाएगा? माइनस डो रो v आ जाएगा, because in y direction velocity is v divided by dou y into dy आएगा, dy into dx dz. So this value will be dx dy dz only. Similarly in z direction, so z direction क्या हो जाएगा? is equal to minus dou rho into w by dou z into dx dy and dz. ठीक है? So now three equations we have, 1, 2 and 3. Now this is an unsteady flow. I am not taking any assumptions. So first thing I have considering here 3-dimensional. All 3 dimension I am considering. That's why the net mass transfer in x direction we calculated, net mass transfer in y direction, net mass transfer in z direction. Now I am going to write the unsteady flow energy equation. So unsteady flow energy equation, what I told you, that the net rate of mass accumulated within the control volume is equals to net rate of mass transfer across the control volume. जो भी पूरे कंट्रोल वॉल्यूम से नेट ट्रांसफर हो रहा है वो नेट रेट ऑफ मास ट्रांसफर और जो चेंज होगा कंट्रोल वॉल्यूम का मास उसके बराबर होगा. सो नाउ आई विल अप्लाई मास बैलेंस. Now I am going to apply mass balance. So what is mass balance? I can say that dou by dou t of what? Mass of control volume. Now what is the mass of control volume? What is mass of control volume? Is this is a control volume. This is a control volume. So mass of control volume will come how much? I am writing somewhere here. Mass of control volume value will come rho into volume. Rho into volume is dx dy and dz, right? Okay, so this value will come. So dou by dou t of rho into dx dy and dz. This is the rate of mass accumulated within the control volume is equals to net rate of mass transfer across the control volume in all the directions. So basically it will come minus dou rho u by dou x dx dy dz. This is minus only, so minus I'll take outside, plus dou by rho into v by dou y into dx dy dz, plus dou by dou z of rho into w into dx dy and dz. See, dx, dy, dz is going to be common, and this is also dx, dy and dz is independent of t. So what is going, this term is going to be cancelled. So left hand side what you will get, dou rho by dou t. Left hand side what you will get, next slide I'm writing, left hand side you will get dou rho by dou t. Right hand side what you will get, right hand side basically you are getting this term dx, dy, dz will be 0. So minus of dou rho u by dou x, right? So this value will get minus dou rho u by dou x plus plus dou rho v by dou y plus dou rho w by dou z, right? So take this in left hand side. So basically you will get dou rho by dou t plus dou rho u by dou x plus dou rho v by dou y plus dou rho w by dou z. Now this is the general form of continuity equation. This can be useful for study as well as unstudy. This can be used for incompressible as well as compressible. This can be used for 1D, 2D, 3D, whatever it may be. So this is a generalized condition. Now let's say case 1 I am taking here. If flow is steady, right? If flow is steady, then first term will become 0. Right? So equation will come how much? Only steady, but it's not incompressible. It is a compressible. Steady and compressible, I can say, for your confusion. Only steady and compressible, right? So only steady I am writing, not, it may be compressible, it may be incompressible, both basically, but I am taking compressible only. So in that case, this value will become 0. You will get dou rho u by dou x plus dou rho v by dou y plus dou rho w by dou z is equal to 0. Clear hai beta? Clear hai? Okay, no problem. So this is the equation you are getting if flow is steady. Now case 1, this was case 1. Now case 2, if you will take, then let's say flow is incompressible. If flow is incompressible, then what will happen? Rho value will be constant. Flow is incompressible means rho value is going to be constant. If rho value is constant, then this term, first term will be 0. Here rho will come out and go another side 0. So basically you will get dou u by dou x plus dou v by dou y plus dou w by dou z. Now this is basically what for incompressible flow. Number of time students are thinking that sir, here t term is not there, here time term is not there, that's why it is only for study. No, it is valid for study as well as unstudy. So valid for study as well as unstudy. Valid for study as well as unstudy. Clear hai? Even if it is incompressible study, then also same equation, incompressible unstudy, then also same equation. ठीक है, ये 3D के लिए हो गया. अगर 2D है, if suppose 2D is there, then dou w by dou z value will become 0. So dou u by dou x plus dou v by dou y is equal to 0. That is two-dimensional incompressible continuity equation. ठीक है. So only this much knowledge is required. To solve any problem of continuity equation. Clear है? So let me solve some problem. So are you get to know? Anyone have any problem? समझ में आ गया? Question is visible to you? This is a gate problem only. This is a gate problem. So I want that please once try by your own. Please try by your own. For a minute, please try by your own. Try करोगे? Are you ready to try? So here it is going study incompressible word is there. Beta. Incompressible word is there. incompressible word is there. Please try to solve. PK Nag sir. कुकीशे यो कोकीले, अरे क्या नाम है तुम्हारा भाई, मैं तो प्रोनाउंसिएशन ही नहीं कर पा रहा हूँ. Please try to solve this. It is an incompressible flow. The velocity distribution is given. Velocity vector is given as a 3x I minus py j plus 5z k. Yes, try. Cookie su you lay. Please tell me your correct name. Tell me your correct name, because मेरी फन फॉलोइंग इतनी तो नहीं है कि यार चाइना से भी लोग पढ़ने आ रहे हैं. Try to solve. So if we compare with v is equal to u plus ui plus vj plus wk. So u value will come basically 3x. V value will get minus py and w value will get 5z. जल्दी करेंगे. Solve it fast beta. So now if it is a incompressible, then what will be the equation? Dou u by dou x plus dou v by dou y plus dou w by dou z is equal to 0. Whether it's a study or unstudied, no problem at all. So just put the value. So what is dou u by dou x? Dou u by dou x value will come 3 plus dou v by dou y value will come minus p. This value will come minus p plus this value will come 5 is equal to 0. So p value will come how much? 8. आ गया? Everyone got the answer? Everyone got the answer? Clear है? Okay. Let's solve another problem. A two-dimensional velocity field is given by this one, right? So basically what is given here, v vector is given, that is 10 y cube minus x square y ये क्या, हाँ, x square y I plus 2cxy square j. मुझे एक बार ये क्वेश्चन देख लेने दो कि ये जो स्क्वायर दिया है करेक्ट दिया है कि कुछ गड़बड़ दिया है. मेरे पास इसका चैप्टर का सीट कहाँ गया? जल्दी से सॉल्व करो इस प्रॉब्लम को. मैं एक बार चेक कर लेता हूँ ताकि आपको कोई कंफ्यूजन ना हो. ये भी गेट का ही प्रॉब्लम है, ये भी गेट का ही प्रॉब्लम है. लेट मी चेक दिस. वेयर इज दैट शीट गॉन वेंट? ओके, हाँ, 10 वाई क्यूब एक्स माइनस एक्स स्क्वायर वाई, ठीक है. और क्या है? एंड आफ्टर दैट 2c एक्स वाई स्क्वायर जे. 2c ठीक है. क्या निकालना है? क्या वैल्यू ऑफ सी. ओके, नाउ प्लीज लिसन हियर. करेक्ट है वैल्यू, करेक्ट वैल्यू गिवन है. सो u का वैल्यू क्या हो गया? u का वैल्यू हो गया 10 वाई क्यूब माइनस एक्स स्क्वायर वाई. v का वैल्यू हो गया 2cx वाई स्क्वायर. सब लगाओ. डो u बाय डो एक्स. डो u बाय डो एक्स का वैल्यू क्या आएगा जरा देखो. इधर 10 हो जाएगा, ये टर्म तो 0 हो जाएगा, और इधर आ जाएगा माइनस का 2xy. एंड डो v बाय डो y का वैल्यू क्या हो जाएगा जरा बोलो. डो वी बाय डो वाई का वैल्यू हो जाएगा 4cxy and this value must be 0. So I can say that from continuity equation dou u by dou x plus dou v by dou y is equal to 0. So 10 means minus 20xy plus 4cxy is equal to 0. So xy gone, 4c value is equal to 20, तो c value is equal to 5. 5 आ रहा है, कितना आ रहा है देखो, कोकी सा यो लोली, right? Are you getting 5 value? Are you getting 5 value? Are you getting 5 value? Everyone tell me fast. Everyone tell me fast. Everyone tell me fast. Okay, let me move to the next problem. A compressible fluid is flowing in a steadily through a pipe which area is reduced 40% from section A to 2, right? So A2 value will come how much beta? A2 value 40% is reduced, means 60% is remaining, 0.6 times of A1. Further known that corresponding reduction density ρ2 value is 15% is reduced. So how much is remaining? 0.85. Yes, 85 ρ1. Okay. Compare the velocity of sector 1 and 2. Right. So it is a steady one-dimensional flow basically. So I can say ρ1 A1 V1 is equal to ρ2 A2 V2. Right. Just put the value ρ1 A1 V1 is equal to ρ2 value is 0.85 ρ1 into 0.6 A1 V2. Now we have to find out, compare the velocity of fluid 1 to the velocity of fluid 2 increased by the factor. So V2 will be increased by which factor? V2 value will increase by which factor? So this ρ1 A1 cancel, ρ1 A1 cancel. So V2 value will come 1 by calculator है किसी के पास? You have calculator? I don't have calculator here with me. Calculate fast. V2 is equal to some factor by V1. So how much that factor is coming? Just tell me fast. जल्दी बताइए, जल्दी. I don't have calculator here. Where is my calculator? Who have stolen my calculator? Tell me. कैल्सी बहुत चुराते थे बच्चे क्लास में. मिल गया. I got it. So 1 by 0.85 divided by 0.6. 1.96. Yes. So A is the correct answer. Everyone got the answer here? Everyone got the answer? Shall we move for further? Okay, let's move. Now, the velocity component in x and y direction is given. Okay, u value is given, v value is given. What is the lambda for incompressible? Okay, so apply dou u by dou x plus dou v by dou y is equal to 0. What is dou u by dou x? Dou u by dou lambda y cube minus 2xy plus dou v by dou y 2xy minus 4 will come, so 3y cube. 3y cube is equal to 0. So this value will become 0. Y cube, well, lambda value will come 3. Most easiest problems are coming from this particular topic. Problems are coming from this topic. But this topic is very important for further study. If you don't know about continuity equation, you will never able to apply Bernoulli equation correctly. And you will never ever able to understand what is the acceleration of a fluid particle. So tomorrow I am coming with another capsule, that is acceleration of a fluid particle. Day after tomorrow I am coming with a velocity potential function and extreme functions, right? Then after that it will depend upon your response. So if you people are coming regularly, consistently, and you are watching these lectures, you are liking the session, sharing the session, then only I'll continue these series in future. Okay, let me solve one more problem for you. The velocity functions are given. Velocity, this is basically u, this is basically u, this is basically v, and this is basically w. Okay, and density variation is also given. In order that mass is considered value of lambda, so basically this value will come out dou rho by dou t, general equation, dou rho by dou t plus dou rho by dou t plus dou rho u by dou x plus dou rho v by dou y plus dou rho w by dou z is equal to 0. Now rho is function of time, but rho is not function of x, y, z. It means that for x, y, z rho value is constant, so rho will come out basically. So this value dou rho by dou t value will come how much? That is rho naught e to the power minus 2t, and this minus 2 basically, minus 2. Correct hai? Check karo. Plus rho will come outside, dou u by dou x, value will come 5, dou u by dou x value will come 5, plus rho value will come out, dou v by dou y value will again come 5, plus rho will come out, this value will come lambda is equal to 0. And this is what? This is basically rho only. This is basically rho only. This is basically rho only, right? So this value will come minus 2 rho plus 5 rho plus 5 rho plus lambda rho is equal to 0. So this value will come how much? 5, 5, 10, 8. So lambda rho is equal to minus 8 rho. So rho cancel out, lambda value is minus 8. This problem was asked for 2 marks. Okay, so these type of problems you have to practice, and please try to come in live only. Please attend these capsules in live only. I am not wasting the time. So you can see that within 40 minutes complete continuity equation is done with 1-dimensional, 2-dimensional, 3-dimensional, compressible, incompressible study along with 5 problems. So I hope I am not wasting your time. So please come on live only. Okay, now I am going to share one information just for 2 minutes, that one Udaan batch is launched where all the top faculties are going to teach. This batch is already started, going to start from 21st December. And if you want to take, this is for GATE 2024. If you want to take admission in this batch, then you have to use my code, that is Shivam101. If you use this code, then you will get maximum discount. Along with that, you are going to get my personal guidance. Throughout your career, throughout your preparation. Okay. Next one is Buniyaad batch. This Buniyaad batch is basically for GATE 2025 students, right? And this is also started from the 21st December only. And here also all the top faculties are teaching. And if you want to take admission in this particular batch, then also again you have to use Shivam101 to get maximum discount, as well as personal guidance, interview guidance, DPPs, everything you will get. These are the USPs of these batches, right? These are the USP of this particular batch. Okay. Next if I say, then here if you see, our batches are announced for upcoming GATE exam, right? And if you want to take admission, then this is the best time. This is basically the best time. Why this is best time? Because the price is their lowest. You can see that for 15 months subscription, you have to only pay 30,000, and you have to use my code SHIVAM101. If you use this code, you will get the product at very low cost. Along with that, you will get my personal guidance, DPPs, notes, everyday practice sessions, everything you are going to get from here. Okay, so these are the price structure. You can see Then IRMS students, we have already launched IRMS batch, right? We have already launched IRMS batch, where again all the top faculties are going to teach, including me. And in this batch you will get all the technical things, right? Means all the what you call technical part, technical subject, conventional objective, everything whatever is required for IRMS you will get it. And not only that, non-technical part also will get by the top faculties of Unacademy. Top faculties of Unacademy, you are going to get the UPSC general like GS part also. GS part also you will get, and that too also you have to pay very less. Even if you are taking for 1 year and if you are using my code, then you will get complete thing in 63,661, along with my obviously my guidance will be there. Now last but not the least, Unacademy already launched All India mock test for GATE 2023. All India mock test for GATE 2023, right? So 1, 2, 3, 4, 5, 6 mock tests are provided for you, that is free of cost, where you will get all India ranking, and these tests are basically prepared by the top educators, right? And if you use my code SHIVAM101, then you will get all these tests free of cost. Free में लेना अच्छा लगता है ना, तो ले लो. Chalo. So this is all about today's capsule, right? Let's meet at tomorrow at 6 p.m. This is my humble request from all of you, that come live only. Why? Because you are watching recorded, then I will not able to continue this series long, right? So come live only, okay?